Do you like quadratic equations? How about quadratic-like equations? What do I even mean by that? So in this section, we're solving quadratic-like equations, whatever those are, and the goal is to solve equations that can be thought of as quadratic but aren't necessarily quadratic. Huh? Well, I'll get there. In this example, part A, we're asked to solve y minus 3 quantity squared minus 5 times y minus 3 as a quantity plus 6 equals 0. This is actually a quadratic equation. If you were to multiply it out, combine like terms, you would get the familiar form, not ax squared, but ay squared plus by plus c equals 0. You'd get that familiar form. But there's an easier way. There's an easier way to solve this, and that's because that quantity being squared is that y minus 3 is the same as the quantity you're multiplying times that minus 5. So you can do a substitution. So what do I mean by a substitution? You're going to replace y minus 3 with another letter. Usually we call it a U-substitution if U is not being used in the equation. I'm going to call that y minus 3 quantity U. I'm going to say let U equal y minus 3. And if you actually make the substitution, so you're going to take this guy and you're going to substitute it. And what equation do you get if you make that substitution? Yeah, exactly. U squared minus 5u plus 6 equals 0, which is a lot easier on the eyes, isn't it? In fact, what method might you try before you jump right to the big guns of the quadratic formula? Try factoring it. It might just factor. In fact, most of the problems in this section will factor. Not all of them, but most of them. So when there's a 1 as your lead coefficient, it's the very systematic method. There's no trial and error, right? You unfoil it, and you look for two numbers whose product is what, and whose sum is what? Product is 6, and the sum, -5, right? So what are you going to get? Minus 2, u minus 2, and u minus 3. Okay, then what do we do with both factors? We set them equal to 0 and solve. Now, would you like to skip that step? I would. Because you know what you're going to get when you set u minus 2 equal to 0 and solve. What do you get? U equals 2 or u equals 3. Now, what's the problem? Have we solved for the given unknown, which was y? We haven't. So we're not done. You've got to substitute back. It's easy enough, you guys. Look. U is equal to y minus 3. So what I could do is I could back substitute y minus 3 where the u is, and then solve that simple equation. So I get y minus 3. If u equals 2, y minus 3 equals 2. Or if u equals 3, y minus 3 equals 3. So what happens when I solve those little equations? In other words, I'm going to add 3 here, I'm going to add 3 here. What do I get? So I get y is 5. Or, so in other words, well, I didn't show all the work. I needed to add 3 on both sides, right? So I get y equals 5 or y equals 6. And then I'm done. Now that is less work than multiplying out y minus 3 quantity squared, distributing the minus 5, and then going about solving it. So it's a trick for solving problems easier and faster.